Alrighty, welcome back. So we're going to continue on, but instead we're not going to be finding the domain. We just did that. Now we're going to be focusing on finding the range. Now remember, range relates to the y values. So it's going to be really similar to the domain, where in the domain we were seeing for what graph, for what parts of the graph did we have x values for. Well, because range is the y values, now we're saying, okay, for what parts of the graph do we have the y values for? Alright, now this one's a little bit harder to think of, but it's still not too bad. So let's imagine for this first graph, right? We look at the y values for this. We'll notice that we have 1, right? If we were to squish this graph now horizontally onto the y-axis, alright, we'll notice that you have values, right? If you were to squish this all on, we have values for all this. Now, don't be fooled. Yes, we have this open circle here, but if we were to squish it, we'll notice that on the other side of our graph, we have the same y value on a different x, and that's what matters here. There actually isn't a break, so the lowest point of the graph is at 1, right? There's definitely one point where the value is there. They're both we see 2 points. Both are closed circles, but as long as we have any line there, that technically counts as being a closed circle there. Alright, and we'll notice that this arrow also helps us out here, meaning that it's going to be going up forever. Yes, it is also going to the right, but we really care for range. Anyways, for range that we care that it's continuing going up, meaning it'll keep going up forever until it hits infinity. So you really just say, what's the smallest y value you see to the largest y value you see? Okay, that's all range is looking for. If you were to imagine squishing the graph onto the y-axis, what y values, where would it be on the axis? Right, same thing here. I'd say, right, the lowest point of the graph, the smallest y value. Well, notice it's going to be right here on our that 4, 0 point. And specifically, what we care about is that it is at the 0 point, meaning that the y value, the smallest y value, is 0. We have a closed circle there. And then the largest y value is going to be infinity. Because we'll notice this arrow, while it's going more to the left than it is going up, it is still going up. Alright, and then that would be the range. Okay? Next one. So again, we look for the smallest y value, right? Where's the smallest y value we see on the graph? That's the lowest part, and that's going to be here at -5. Alright? Now you might be wondering, Miss Diddy, is this a bracket or a parenthesis? Okay, well think about it this way. Do you see an open circle? No. And if you don't, then it has to be closed circle, right? Open circle specifically tell you that there is a break there, right? Now this closed circle here we see on the other end of the graph, that is optional. You do not have to see a closed circle there for you to assume it's closed circle. Okay, for the most part, you can always assume that it's closed circle unless it's denoted otherwise. Okay, so we have a closed circle there. And then as we keep going, we'll say, what's the highest point on the graph we see? Well, that's going to be at 4, right? And then we actually see the closed circle there. Alright, now this open circle that we see over here on the side, right, this open circle, that doesn't matter. At least not for range, because you'll notice that on the same y value, we actually have that point, right? Remember, we're assuming that it's a closed circle unless otherwise stated, so technically we have a big old closed circle there. That means that at some point, the value exists for y there, so we don't have to create a break in the interval notation, because it is there. There is a y value for it. Alright, so that would be the range for that problem. Alright, next one. Our smallest y value. Well, notice our smallest y value occurs all the way along here. And we notice we have at least one closed circle, right? We have the value at least once at -2. So we use a bracket. And the highest point of 2 is going to be here on the graph, and I'd say, great! The highest point is at +2. We don't see any open circles, so we assume they're closed, and we use a bracket to denote closed circles. One last one. All right, the smallest point on the graph, well, note is that some of you might be tempted to look here for your smallest point, but this arrow actually tells you the smallest point. That arrow tells us that you're continuing forever in the negative direction, meaning that you will eventually hit negative infinity. All right, range is not dependent on what you see on the graph. Range is for all values ever. Okay, and on the other side, we'll see that same arrow, meaning it's going to the positive forever on the other side. So your range is going to be negative infinity to positive infinity, or you can say all real numbers. Okay, but for your homework, you are going to be writing in interval notation, so you will just put negative infinity to infinity on those ones. All right, there you have it. Okay, so that is range. Thanks for watching.